There is a moment, rare and almost never filmed, where a fully grown wild wolf, an animal built by 3 million years of evolution to treat every unfamiliar creature as a potential threat, goes still in the arms of a human being. Not sedated, not restrained by force, still. Its breathing slows, its muscles, coiled a moment earlier for flight or attack, simply release. Every instinct this animal has ever inherited says this should not happen. A wild wolf that lets a human hold it is not behaving like a wolf. It is behaving like something evolution never designed it to be, and understanding why forces us to question where the line between predator and trust actually sits. The paradigm shift. The classical assumption is simple. Fear keeps wild animals alive. A wolf that hesitates near a human, that doesn't immediately flee an unfamiliar large mammal, should be selected against. Evolution should have erased any wolf calm enough to be approached, long before it had the chance to pass on that trait. And yet field biologists and wildlife rescuers have documented this exact scenario repeatedly. An injured wolf, caught in a snare or trapped in ice, that stops struggling the moment a human begins to help. Not because it recognizes help as a concept, it has no framework for rescue. But something in its nervous system makes a calculation faster than conscious thought ever could. This isn't submission in the way we typically imagine it. It's something closer to an ancient risk assessment system reaching an unexpected conclusion. The deep dive. To understand this, you have to understand what fear actually is, biologically. Fear in a wolf is not an emotion in the human sense, it's a cascade. The amygdala detects threat. The hypothalamus triggers the release of adrenaline and cortisol. Heart rate spikes. Blood flow redirects to the muscles. This is the sympathetic nervous system preparing the body for exactly two options, fight or flight. But there is a third state, less discussed, called tonic immobility, sometimes nicknamed freeze. It's not paralysis from terror in the way we picture it. It's a parasympathetic override, a biological last resort when an animal calculates at a level beneath conscious thought that neither fighting nor fleeing will improve its odds of survival. In a trapped, injured wolf, one leg caught in a snare, exhausted from hours of struggling, its blood sugar collapsing, its adrenal system depleted, the body eventually runs out of the resources needed to sustain fight or flight. What replaces it is not calm in the emotional sense. It's a physiological shutdown, a conservation state, where the parasympathetic nervous system takes over and slows the heart, lowers cortisol, and produces exactly the stillness we mistake for trust. This is the mechanism behind why so many rescued wild animals go quiet in human arms at precisely their most vulnerable moment. Not because they've decided we're safe, but because their body has run out of every other option. But that alone doesn't explain everything. Because in many documented rescues, the wolf doesn't simply go limp from exhaustion. It responds specifically to the human's behavior. Rescuers who approach slowly, who avoid direct eye contact, who keep their movements low and their voices quiet, succeed far more often than those who move quickly or loom over the animal. Direct eye contact in wolf body language reads as a challenge. A crouched, non-threatening posture reads as the opposite, the same signal a wolf gives another wolf during a submissive greeting within its own pack. Humans who instinctively or deliberately mimic these signals are, without realizing it, speaking a dialect of wolf social language that predates our species by millions of years. This means the wolf isn't simply broken down by exhaustion into passivity. It is actively reading the human as a specific kind of threat, or non-threat, using the exact same neural circuitry it would use to interpret another wolf. There's a deeper layer here too, rooted in oxytocin, the neuropeptide associated with bonding, trust, and social affiliation in mammals. Oxytocin isn't unique to humans or to domesticated species. Wild wolves produce it during pack bonding, during pup-rearing, during cooperative hunting. Researchers studying stress physiology in canids have found that gentle, slow physical contact, the kind used in careful rescues, can trigger oxytocin release even in an animal with no prior positive history with humans. That release does something specific. It dampens the amygdala's threat signal. It lowers cortisol further. It creates, chemically, a small window where the nervous system stops preparing for danger and allows something closer to relational calm. This is not the wolf deciding to trust. It's a 30-million-year-old mammalian bonding circuit, built for parents and packmates, misfiring, or perhaps functioning exactly as it was designed to, in response to a set of signals it was never built to distinguish from its own kind. Consider the specific physical reality of this moment. A 50-kilogram wild predator, capable of crushing bone with over 400 pounds of bite force, held against the chest of an unarmed human being, its heart rate slowing, its eyes half closed. Every piece of its evolutionary architecture for self-preservation is technically still intact, and yet, in this specific window, none of it fires. The philosophical climax, so what actually happens in that moment? We want to call it trust, because trust is a word built for human relationships, and it flatters us to imagine a wild animal choosing to believe in us. But trust implies a kind of narrative memory, a story the wolf tells itself about who we are. The wolf has no such story. What it has instead is older and, in some ways, more remarkable. A nervous system so finely tuned to detect the subtle physical signatures of safety, a slowed heartbeat nearby, an averted gaze, a lowered posture, careful hands, that it can suspend 3 million years of predator caution based on nothing more than body language and hormonal chemistry in real time without a single word exchanged. This suggests something uncomfortable for how we think about the boundary between wild and tame. We tend to imagine that boundary as fixed. An animal is either domesticated, safe, predictable, or it is wild, dangerous, unknowable. But the wolf in a rescuer's arms occupies neither category. It is fully wild, fully capable of violence, and in that specific moment, fully calm. Not because its wildness has been removed, but because a much older system, the one built for trust between its own kind, has been activated by accident. If an animal capable of tearing through muscle and bone can be calmed entirely through posture, pacing, and the right chemical signal, then the line we draw between civilized and wild may say less about the animal than it does about us, about how rarely we offer another creature the specific conditions its nervous system was built to recognize as safe. Every wolf carries, somewhere beneath its fear, the same circuitry that lets it curl beside its pack in silence. That circuitry doesn't know the difference between a packmate and a stranger who happens to move the right way, at the right pace, with the right stillness. It only knows the signal. And for one suspended moment, in the arms of someone it should have every reason to fear, the wolf chooses, or perhaps is simply chemically guided, to answer that signal as if it had known you its entire life.